everyone, welcome to Coders Art. So today in this video we are going to learn about the topic database management system, which is DBMS. So database management system is a really crucial topic which is applicable everywhere. We are going to learn about these things. This is the outline which we are going to cover in this video today. It is first we're going to discuss about what are databases. In fact, you must have heard about the growing need for databases in today's world because of the increase in data. In fact, there are various sources of data. Data can be structured data, unstructured data, or even semi-structured data. So how do we need a place or a systematic way in which we can organize this data. So that particular databases is one such way for us, a means for us to store and organize the data. So we're going to learn about what exactly are databases, the basic definitions associated with database management system, which is very much essential for us to organize the data, and why DBMS, which stands for Database Management System, is used. We're going to learn about typical DBMS with architectures, the various data models and architectures, also some of the properties of DBMS or the characteristics of DBMS. Then we're going to learn about something called structured query language. Now, structured query language is the language which is used in order to access information, in order to manipulate, access, retrieve information from the databases. So we're going to learn, we're going to have a practical demonstration as well of all the SQL, the major SQL commands. We're going to learn about what exactly are keys, what are constraints in DBMS, and about T-SQL. T-SQL is the structured query language for transactions. So whenever we are making transactions and performing on databases, we are going to use T-SQL. Then we're going to learn about what are the advantages of using the database approach, that is DBMS, and where should we not use databases. Now you must be hearing that there in the older days there were file systems available. Even nowadays we have file systems for storage, because when I said another alternative for this database, like databases especially for storing data, so one alternative for storing data could be file systems. So we need to understand that why we should prefer databases and sometimes not go with the traditional or the conventional file systems. So we are going to learn about the advantages of databases and also discuss some of the approaches in order to normalize the data available. Now, normalization is a term for reducing the redundancy of data or preventing the data redundancy. So with this, I mean that whenever you have humongous amounts of information or data rather, the data present in the tables become really redundant. That is, they're not actually useful. So we have to now, in order to eliminate the duplicacy in the data, so there are sometimes duplicate records available in the tables of the database, you have to remove the duplicate records. So all those processes is handled by normalization. So there would be different various forms of normalization as well. While I'll be explaining in depth, I'll be telling you about the forms of normalization, like first order normalization, second order normalization, third order, fourth order, and so on. Then at the end, I'm going to also discuss about joins by giving you a brief introduction about what exactly are join operations while performing on databases, where exactly they are used, and what are the different types of joins. So let us begin with firstly what exactly are databases and types of databases. So as I was saying that these are very recent applications, that databases are basically they are for storing humongous amount of data. So the use of database is to organize the data from the various data sources, and we must understand that the databases can be of two types, which is relational databases and non-relational database systems. So when I say talk about data in particular, it can be image data or video data. It can be textual data as well. So you can see here traditional applications which were previously used, they had the numeric and the textual databases available. And the more recent applications, they are like, these are the types of the recent applications which store multimedia, geographic information, data warehouses, and real-time and active databases, and many other applications. So before we used to have file systems available for storing, but then nowadays we can see that a lot of data, we have different kinds of databases. To name a few, the very most popular one is MySQL, which I'll also be showing you the demo later about how we can leverage SQL commands, which are a structured query language, in order to access information, retrieve, and update the data present in the relational database management system. So when I talked about the term relational, and a relational database basically implies whenever it is used for the term when the database is in tabular format. So when the data present in this relational database is always in the tabular format, because the word relational means a table. Whereas a non-relational database, in that case, you do not use SQL commands there, but you use no SQL commands. So in this video, we are going to learn particularly focusing on relational database management system and SQL in order to access information from RDBMS. Coming to the non-relational database management system, it is more dynamic in nature, but the data over there can be semi-structured and unstructured as well. So there are cases where we have a lot of unstructured data, half is our data. So for that cases, we use a non-relational database management system, because in those scenarios of non-relational database system, for example, MongoDB is an example of that. Neo4j is another example of, so in non-relational database system, let me give you an example. For example, the data is not stored in a tabular form for tabular format, but rather is stored in the form of documents or in the form of graphs. So you use graph-based database system, key value pair. It's stored in JSON format, or it's stored rather in a document format. So you go for MongoDB or you go for Cassandra. These are some examples of non-relational database management system. But coming to RDBMS, which is relational database management system, the data is to be arranged in the form of tables. And tables, it consists of rows and columns, and it means the data is already structured data. So these are some of the recent applications of database. Now, the DBMS contains information about a particular enterprise. There are a lot of companies which are storing their data and the collection of interrelated data into their databases. So you must have heard about data warehouse, data structures, and other terms also. But there are differences between these terms. Database is different from a data warehouse, data lake, data source, and also from a data structure. Data structure is where it is for the arrangement of data, but it cannot handle voluminous data. But then when the data is humongous, and especially at the enterprise level, where the data is to be in the form of rows and columns, for that particular cases, we go with databases. And the most excellent example of RDBMS is MySQL database and Oracle database, because over here, and these are the examples of relational database systems, and on them we use the SQL commands. So a collection of interrelated data is nothing but a database. It's a set of programs to access the data and an environment that is both convenient and efficient to use. We're going to also look into why exactly it's termed as convenient and efficient to use, and why exactly the companies are storing their data in the database. And also you have to understand that SQL these days, there are a lot of plenty of jobs available in the market for SQL. So it becomes really important for us to understand the DBMS concept and to have a good understanding of the SQL commands as well, because SQL nowadays it's becoming an important skill, especially for the data analytics domain. Also for database administrators, it requires the knowledge of SQL. So there are a lot of jobs which you can get by learning SQL. So thus it becomes really important for us to know. So database applications, there are various applications where exactly databases are used. Like when I said enterprises, banking, or like I've mentioned T-SQL. T-SQL stands for transactional SQL. So for all kinds of transactions you have in banks, databases are used. Then there are airlines available. So to make reservations, schedules, to store the data of the passengers everywhere, we leverage the databases, especially in the airlines and airports. Universities are also using databases. So even companies, to store their employee records, to store their employee information like the date of joining, their registration number, their department they are working, these all are contained in an employee database. And in a database, you must understand that there are millions and millions of relations. Really, with relations, I mean there are a lot of tables available. The tables it consists of rows and columns, and there are a lot of, you can understand that one single database can have multiple tables. Of course, you can set a limit to the number of tables which can be stored in a database, but then there are maximum, you can set the limit, but then there can be more than one table in a database. And it also allows concurrency in it. So if not only a single user can have the access to the particular table in the database, but also many users, multiple users at the same time can have access to the information or the data which is present in the database. So a lot of universities having storing the student records, grades, registration numbers are using databases. Sales, online retailers, manufacturing, production, human resources to store the employee records, salaries, tax deduction, and etc. So we can understand that it's applicable in every aspect of our life. Some of the basic definitions you must be aware of, as I've already covered. What is a database? It's a collection of data, interrelated data, and data. You know that what is the major difference between a data and information. So information is something which makes sense. So we can say it's meaningful data is called as an information. But data, on the other hand, they are known facts that can be recorded and have an implicit meaning. So sometimes the data may not actually imply anything. It can be redundant data because some data can have outliers as well. So you must have heard about the tables which are having empty records in them. So even the missing data, missing value, a table having the missing information, that is also termed as data. So that is why in data warehouses, databases, there is a lot of pre-processing done. And pre-processing is that stage where we are applying all the data cleaning methods in order to clean the data. So you have to learn about, I'm just covering the important terms you must be familiar with. Then database management system, software package or system to facilitate the creation and maintenance of a computerized database. An example could be MySQL and Oracle. The database system, the DBMS software together with the data itself is called as the database system. Sometimes the applications also included. Then why do we use DBMS? So the purpose of using a DBMS is for data independence and efficient access. As I also covered the point that also that multiple users can have access to the data present in the data DBMS concurrently at the same time. So for the multi-user access concurrently, we use DBMS, and also for reduced application development time, data integrity and security. I'll come to the term associated with DBMS, which is called asset properties. While I'll be discussing about the characteristics of DBMS, one important information is asset properties, which are the major properties of DBMS due to which we are relying on DBMS actually. With asset properties, it means A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So with these properties, it makes the users really reliable. It makes the databases for us really reliable. So that's why the users are actually making use of the database management system and storing all the data inside tables, relations of the database. So when I say data independence and efficient access, it means that the any changes which are done on one table of a database do not have any effect or do not have a direct impact on the data of the table present in the other database. So they're independent of each other. Also, there is reduced application development time because it speeds up the process. There is query optimization technique, and there is a component of DBMS called query optimizer. There are different components also like transaction manager and so on. They reduce the application development time significantly. Then there is data integrity and security. Database management system as compared to files are really secure. So when I was talking about file management system, one disadvantage that people observed in the history is that their files were easily corrupted. They could be hacked. So that is why they were switching to storing data in the DBMS. So it's more secure. Also, there are different SQL injection techniques and so on, which help us to ensure the security of the data. So also uniform data administration. That's why DBAs, which stand for database administrators or database admins, they have an advantage over here when they store the data in their DBMS, the databases, because there is uniform data administration. Also, the concurrent access recovery from crashes. So this is implied by the term, which is D term, which is durability. When I was talking about the asset properties, the last term, which stands for durability, in the acronym of asset properties. So over there, recovery from crashes is nothing but durability. So whenever there is a crash in the database, it will not impact or hamper the process. So the data will be consistently flowing. There is consistency ensured, and all the operations which are performed on the database are not impacted because there is speedy recovery from the crashes. So that is called as a durable property. We can term them that the databases are durable. in nature. And also there is concurrent access and consistency is ensured. That is, the operations are independent of each other, data operations in the transaction, and also they are the property of either the change which is done by the user on the database is done completely or it is not done at all or none property, which is a very important feature of atomicity. The first letter of ACID, which is atomicity, that is nothing but ensured by all or none. That is nothing but if the user makes a particular change in the database, the database management system, it ensures that the change is either applied or committed. That is, it's saved and applied to all the records in the database, or it is not done at all. But it will not be a partial transaction at all. It will always be a all or a none way. So why study databases? When I'm talking about these advantages of databases and all, you have to have a clear understanding of why do we study databases. Of course, databases are really important and growing demand these days in data engineering fields, also data pre-processing, data analysts. So the very requirement of databases, it is because from the shift from the computation to information, at the low end scramble to web space, and at the high end scientific applications. So it means that databases are also used in scientific applications, web applications, and so on. Especially when you're talking about web applications, there will be a front end and a back end of a web application. So you know that the front end of web application consists of mostly the front end languages, the web development languages, which are HTML, hypertext markup language, then CSS, cascading style sheet, there is JavaScript, and so on, even React.js. But then on the back end, you should have a database to store all their data. So mostly the common database used is MySQL, but then in cases where there is unstructured or semi-structured information, people also use MongoDB. That is a non-relational database. So that is where in web applications these days and even scientific applications, we are using databases. So there is a shift from computation to information, because information needs to be stored in a tabulated form, in a very organized form for us to access later. Now, data sets increasing in diversity and volume. So there is always, you must have heard about the three V's, which stand for velocity, veracity, and the volume, veracity, and velocity. So it is because of the voluminous data firstly, and also the speed or the veracity is the diversity of the data, the variety and the different kinds of data which are available, and also the speed at which the data is changing rapidly, which stands for velocity. So that because of these characteristics of data sets are increasing activity in diversity and volume. So it becomes really necessary for us to store such kind of information, which is changing really rapidly and also is voluminous in nature, into a database. So there is digital libraries, interactive video, human genome project, EOS project, and so on. So these all require the need for DBMS exploring. Then DBMS encompasses most of the CS. CS is computer science. So there are operating system, languages, theory, AI, multimedia, and logic. These are the different paradigms of computer science which require the knowledge of DBMS. So when I was talking about files versus DBMS, so application must stage large data sets between main memory and secondary storage. Example, buffering, page-oriented access, 32-bit addressing, etc. Special code for different queries. Must protect data from inconsistency due to multiple concurrent users. So when I was talking about the security as the feature of DBMS, which ruled out why files should be used. So this is why people switched from the file management system to the database management system, because DBMS ensures security of the data, also to protect the data from inconsistency, because it has a property of consistency to allow multiple users to concurrently access the information present in the databases. That is where people switch from file management system to DBMS. And also for voluminous data, as already discussed, then durable, that is crash recovery, security, and access control. Purpose of database management systems. So these are some of the drawbacks of using file systems to store data redundancy and inconsistency. So when I said redundancy, it's nothing but duplication of information in different files. Files can be either corrupt or they can also have a lot of duplicate information which does not make sense, is repeated. So in order to handle such data, we have to first pre-process the data, store it and organize it in a way so that we can eliminate the duplicate records or the duplicate rows of the data. So for doing that, we are making use of database management systems. And to talk, when I told about the term normalization, that is exactly what duplication, that is what exactly the elimination of duplication is performed there, where we are removing all the unnecessary or the repeated information. Then difficulty in accessing the data. When you have a file, there is need to write a new program to carry out each new task. But then, whereas in a database, there it becomes much more efficient, easier, and convenient for us to access the data, because we are accessing data of a database via SQL commands, the structured query language. So that is much convenient for the users as compared to accessing the programs or the files which are present in different locations of their PC. Also, there is data isolation, that is multiple files and formats which can be stored in a database. There are integrity problems which are observed in the file management system. For example, with integrity, I meant integrity constraints. Example, account balance greater than 0 become buried in program code rather than being stated explicitly, and hard to add new constraints or change existing ones. So this is exactly what is eliminated when we are using database systems. In database systems, you have the option of adding constraints to various columns of a table. A table consists of rows and columns, so you can apply various constraints to the columns or the attributes of the table. Columns are nothing but attributes. The other word for columns is attributes in the database system language, and for rows it is called as records. So you must be familiar with these terms. And also the number of rows present in a particular table, or a table, another word for table in DBMS language is a relation. So that's why it's called as relational database management system. So in a table or in a relation, the number of rows or the number of records is determined by the term cardinality, whereas the number of columns present is the number of rows is called cardinality, whereas the number of columns is nothing but the number of attributes, because attributes imply the columns. So this is why I was saying that we have the option to add new constraints on columns or change the existing ones in the database. So this avoids the integrity problems. Now, purpose of database systems. So there are drawbacks of using file systems, as I told. Another drawback is atomicity of updates. So there may be failures which may leave the database in an inconsistent state with partial updates carried out. But database systems do not allow partial updates to be carried out. They either allow the transactions to be completed all at once or none at all. So if there is a partial transaction, it will not be carried out. In fact, it rolls it back. That is, it undoes the transaction. It undoes the transaction carried out. As compared to the file systems. But in the file systems, if you see, the failures may leave the data present in the file system in an inconsistent state, and only partial transactions can be carried out. For example, transaction can be a very important one also. So when we know that database is also used in bank accounts, transfer of funds is also transaction, and that is a critical operation because we need to ensure that it should be carried out in a wholesome manner. So when there is a transfer of funds from one account to another, it should either complete or not happen at all. It cannot be that the money is transferred from an account, but it's not reaching the other account as well, the recipient only. So that should not happen. Or it should not be the other case, or the vice versa, that the other person is getting, but the money is still not transferred, or something like that. So the partial transactions should not be carried out, but the transactions would be completed all at once or none at all. So that is ensured by atomicity of updates, which is why we are preferring database systems. Then concurrent access by multiple users. As I said, two people reading a balance and updating at the same time without affecting each other. The data operations are independent of each other. That is what is database systems preferred. Security problems are resolved in database systems as compared to file systems. So that was all which offer the solutions to the above problems which were seen in the file systems. All the problems are resolved when you use a database system. Now coming to the next topic of our DBMS, which is the database system environment. Now you must understand what are the different components of a DBMS. DBMS database system. Firstly, the users and the programmers will be there. So the databases are not only accessed by the users and the end users, nothing but the clients or the customers, or even we. we are users. So even the programmers have the access to the database. The users can also have an access. They are database administrators or the database admins. Then we have the database designers as well. So these all people have the access to the database management system environment. Then application programs and queries. So user or the programmers send their application programs or queries. Now queries are nothing but requests to access information from the database. So whenever a user wants to access information, like for example, see a particular record or see all the columns present in the table, or only basically slice the data in such a way that in order to filter information which is required. So when there is a need to filter information of a sort from the table, we can make use of structured query language commands. So we can send queries. So that all is taken care of here in the database system. Then coming to the database software, the queries or the application programs are sent software to process queries or programs. It's sent to this software, DBMS software, to process the query. So this is nothing but the query processor component. I was talking about the query processor. If you if you was in the beginning of the video, talked about the query optimizer as one of the components and the query processor. So query processor will process all the requests or the queries sent by the user or the programmers. Then coming to the next, it sends that processed query to the software to access stored data. Now, once the query is processed, the command sent by the user could be to access stored data. So that is sent to the particular software, which is going to be sent that as metadata. Data within a data is called metadata, and that is sent to stored database definition. And another component of that is a stored database. These are two lower level views of this database system environment. So from here, the database will be, the data from this stored database will be retrieved and then sent back to the user. So this is simplified database system environment. Now, to understand all the typical DBMS functionality. So some of the terms you must be aware of in DBS functionality is what is this the structured query language actually used for. So basically we can, the operations which we can perform on the data present in the DBMS are to define a particular database in terms of its data types, structures and constraints. I'll be explaining you what are constraints. So for now, you must understand we can give a particular definition to the database, a table basically, to the table present in the database. We can define it. Now, when I say define, you can give its the attributes a different name. For example, you can even add different access specifiers to them, or else you can just add them the different data types. So for example, there is in an employee table there is a column which is registration number. So registration number should have a data type of alpha. It's a alphanumeric data type because it can either contain only integer. In that case, you have to give it a int data type, and if it's containing alphanumeric data, you can give it a char or a varchar data type, which stands for variable char or a character data type. So all that would be looked into when I'll be skimming through the slides, and we'll be showing you practically as well. So you can define the data present in the DBMS. You can construct or load the initial database contents on a secondary storage medium and manipulate the database. Now, very important here, manipulating the database means retrieval, modification, or accessing the database. Now, see, you have the read, write, and the execute operations in a DBMS. It's not like you can only just read the data present in the DBMS, or you can not only read, but then you can also write into the database. You can also update by performing the insertions, deletions, or updating the contents of the database. So that is called the modification. In SQL, there are different commands which are associated specifically for retrieval. Then for querying, for creating or defining the data, there is another command. Then for inserting, deletion, for each of these operations, there are different commands. I'll be explaining you that in detail later. Then processing and sharing by a set of concurrent users. Now, to skim over the other features of DBMS. Now we have understood why DBMS is really important. I've talked about the security measure to prevent unauthorized access. Also, there should be active processing to take internal actions on data. There should be there are also another features of DBMS. like presentation and visualizations of data. Now, data visualization presentation is one important thing. That is, after extracting, loading, and transforming the data present in the DBMS, that is ETL or the ELT operations are performed, we must also report the data, or basically in the form of a report we need to present the findings or the insights of the data. Now over there, presentation and visualizations of data help us a lot to generate meaningful insights. So this feature is also ensured in a typical DBMS functionality. Then maintaining the databases and associated programs over the lifetime of the database application, called database software and system maintenance. These are the operations which are looked into. Then from example of a database with a conceptual data model. So this is just an example of a mini world for the example, like part of university environment. The university can have their own database and some mini world entities. Now entities are the tables or the objects. They need not be tables, but they can be other objects as well. So there are different objects of their database or components of a database. So you can have the various entities like students, courses, sections, and so on. These all are the tables of the database basically. So whenever we can consider this mini world to be university to be a database, and then we can have the various tables like the student table containing columns like student information, their registration number, names, phone number, and so on. The courses having all the information, storing all the information of the courses, like the course faculty, the course code, or the course description, the course name, and so on. Sections and courses, academic departments. Similarly, for instructors, we can have the different features of the different attributes for this particular table, like the name of the instructor, the department of the instructor, which subject he or she is teaching, and so on. And departments can have department ID. Now, when I was talking about the student registration number, similarly, the instructor ID or the instructor registration number, these all are unique in nature. Basically, IDs are for the unique identification of a particular student or a particular instructor. So for such columns of the data of the table in which we need unique, we need to ensure that they are unique in nature, basically, that no other student can have the same ID as a particular student. They all are unique in nature. So for those, we can add a constraint which is called as a unique constraint. Now, constraint is a condition. Basically, you can add a condition to a particular column of a table. So that is called a constraint. There are different constraints which I'll be discussing. To name a few, they are unique constraint, which ensures the uniqueness of all the records or all the rows present in the table. Then primary key is another constraint, which ensures that no null values should be present. Along with unique, that is, it also ensures that the rows should be unique in nature. That is, does not contain duplicate information, but at the same time, it will also ensure that there are no missing values or no null values present in the table. So now comes the relationship. Example of a database, conceptual database model. So now you must understand this relationship. What is exactly this relationship in database? Now, databases, there are various attributes, tables of a database. They must be related to each other because, as I've said in the starting, the database contains interrelated data. So in some way, the tables must be linked to each other. Although there is data independence, the operations are not affecting each other. But then we must ensure that the tables are related. So there must be a relationship between them. So now to determine or denote such relationships or associations between the two entities or tables, we need to learn the concept of relationships. And so that those relationship between the two tables or entities can be then demonstrated or pictorially represented in the form of a ER diagram. Now, ER diagram is a entity relationship diagram. It's very important for us to construct the ER diagram, so that because it gives us a clarity as to which tables or relations are connected with each other and what kind of relations they have, whether they have a partial relationship, a complete relationship, parent-child relationship, one-to-one or one-to-many relationship, and so on. So, like for example, here there's a example here. Sections are of specific courses. Students take sections. These are the various ways in which relationships are determined in the database, conceptual data table. Now, this is the example of a simple database, the course database. They are having the different attributes. Attributes of the columns: course name, course number, credit hours, department. Section is another table, grade report, prerequisite. These all are the different tables of a database. Now there must be some relationship between these tables. Those relationships established between the tables are, firstly, we have to write a query for them. Now those queries can be converted in the form of a pictorial representation or a diagram, which is the ER diagram. Then coming to the main characteristics of the database approach, self-describing nature of the database system. So the description is called the metadata. I had showed you previously in the image. There was something called the description of the data, which is nothing but the metadata. Wherever you're passing a query to the database and want the description of that, then the database catalog, which shows the description of a particular database. Now, coming to insulation between programs and data is called as a program data independence. It allows changing data structures and storage organization without having to change the DBMS access programs. Then there is an example of a simplified database catalog, which contains the description as well here. These are the relations basically present, the number of columns, and this is the columns, so exactly the columns which are present. Then coming to the main, so basically when I was talking about the number of columns here, there's a term which is called as a degree. The number of columns is called as a degree, and whereas the number of rows is called as the cardinality of the table. Now, main characteristics of the database approach, we have to understand that there is a lot of data abstraction that should be done, because in order to ensure that there is, now with abstraction, I mean there is a data hiding, that is the lower level information, which are like storage details, are not usually presented to the users. So that is why the data abstraction should be done. There are three levels of database model. You must know that the data model is consists of three levels, which is called the top level, middle level, and the bottom level. The top level is called the view level. The intermediary level is called as the conceptual level, and the bottom level is called as the physical level. So there is a lot of abstraction done in the lower levels, especially when there are storage details available. So those are not presented to the users. So data model is used to hide storage details and present the users with a conceptual view of the database. So conceptual view is nothing but the logical view of the database. It should be presented to the users in the view level. The logical level, but the lower level, which is called the physical level, a lot of data abstraction or hiding is done. Then programs refer to the data model constructs rather than data storage details. It is because we need to some of the details are not exactly required by the users, or even for security reasons we must hide or abstract those information, the details. So that is why we construct. So that is why the programs which refer to the data model constructs rather than the data storage details. Storage details are usually hidden. Then support multiple views of the data. Each user may see a different view of the database, which describes only the data of interest to the user. If the user just wants to see a particular level of data, the view of the particular view of the data, he or she can view only that view of that database. Then main characteristics of the database approach. As I've already discussed about the concurrent users, which have the access to the information present in the database. Then there is concurrency control within the DBMS, which guarantees that each transaction is correctly executed or aborted. So this is coming to T-SQL, where transaction for every, it's nothing but transactions, nothing but the task set of operations or instructions which are need to be carried out correctly by the database in the database. So they should be carried out either all at once or none at all. So that is one important thing. No transaction should be partially completed. So this is ensured by the database approach. As discussed, there is recovery subsystem, which is nothing but even if a crash occurs, it ensures that a complete transaction is always done and permanently recorded in the database. Permanent record in the database is called as the commit command. So there will be a command called commit in the T-SQL, which will ensure that the data, any transaction done, is permanently recorded in the database. And if a transaction is not completed, is not actually affecting, or it's partially completed, we have to undo that particular transaction. So that operation can be undone using the different command, which is called as the rollback command. Then OLTP, which stands for Online Transaction Processing, is a major part of database applications. It's not really used in all database applications, but it is used in data warehouses and database applications. In fact, other database applications where online transaction processing is also done. So database users may be divided into various like actors on the scene, those who actually use and control the database content. So they can be database designers, developers, or even DBA, that is database administrators or maintainers. These are various users which have the access to the information present in a database. Then, as I've already included here, the actors on the scene, which can be database administrator, the database designer, which are administrator responsible for authorizing access to the database or coordinating and monitoring, as the word implies here. The designers which are responsible for defining the content, the structure, the constraints and functions of transactions against the database. Now, end users are the ones which are actually sending in their queries or requests to access information to the data. Now, the programmers, on the other hand, are responsible for the backend part where they actually write the queries and all. But the end users need access to the information. So, there is a front end of an application where they will be just clicking on a button in order to view the data, for example. So, on clicking the button of the web page, the particular action is then sent as a query to the query processor in the database management system, which will then be sent again to the transaction manager, and then the transaction manager to the stored database, which will then retrieve the data from the database and sending in the required information as response to the end users. This all will be done and handled in the backend. But in the front end, the end users, which are using the data for queries, reports, and some of them update the database content. End users can be categorized into casual or naive parametric. So casual are the ones which need database access occasionally when needed. But naive or parametric are the ones which they make up a large section of the end user population. So, for example, bank tellers or reservation clerks who do this activity for an entire shift of operations, and they use previously well-defined functions in the form of CAN transactions against the database. These are the examples for the naive or the parametric, which make up the large section of the end user application. So categories of end users, sophisticated and standalone. So these are the different kinds of end users basically, but we'll be focusing mostly on the DBMS, the features of DBMS and the other things to cover. So these are not in scope for now. So coming to the advantage of using the database approach. Now, as I've already I've already explained that database ensures this sharing of data among multiple users, that too concurrently. So controlling the redundancy in data storage, it avoids or eliminates the redundant records. That is where the redundancy of data is taken care of, it is controlled. Another feature and advantage of DBMS is sharing of data among concurrent and multiple users at the same time, restricting unauthorized access to the data. Whoever you are giving permission to view the data or read and write the data, only that person will be able to view and even read or write the data present in the database. Then providing persistent storage for program objects. Then in object-oriented DBMS, so there are different ways, different types of DBMS, as I was saying, data models like relational data model, which is for when the data is in the form of relations or tables, that is where we are using relational data model. Then there is network-oriented data model. Then we have graph data model and so on, tree-based data model and so on. So in object-oriented DBMS, database management system, that is where the entities, we have objects there. So they are a part of a class, and you must have heard about object-oriented programming. All those standards and techniques of object-oriented programming are followed in object-oriented DBMS. Then providing storage structures, example indexes for efficient query processing. Advantages of using the database approach. Here's one of the more examples which I already discussed, like backup and recovery services and enforcing integrity constraints of the database and so on. Then standards are mentioned. As said, these different basically the history, where how the historical development of database technology was done. That is, previously we did not have databases, we were using files and the data on the web and e-commerce applications which contain data in HTML with links among pages and so on. We used to have XML and another applications which use standards like XML and so on. Slowly we came to JavaScript, PHP and other database updates through web pages. But then the rise of the humongous volumes of data is what gave us the extended database capabilities and have given rise to different types of databases as well. different types of database management systems as well. So this was all about it. And also some disadvantages to be considered. There are two disadvantages which are shown here. Why not to use DBMS? So if the database system is not able to handle the complexity of data because of modeling limitations, this is because we sometimes databases make it really complex, especially the RDBMS or the relational database systems. They make it the data processing and the access really complex kind of a process. So for such scenarios, we can say that DBMS may not be able to be that effective. And also, if the database users need special operations not supported by the DBMS, there are some of the operations which are not supported by DBMS. In such cases, the database users might request for special operations. So these two scenarios are where DBMS may not suffice. So that was all about it in this PPT, where we have discussed basically the introduction to DBMS. And now talking about coming to the keys. I was talking about the SQL commands and all. Definitely I'll be explaining you with the practical demonstration of it now, but firstly we should understand what are keys in DBMS. Keys play an important role in the relational database. It is used to uniquely identify any record or row of data from the table. It is also used to establish and identify relations between tables. If you remember in the previous PPT, I was explaining you that there is a concept of relationships. You need some relationship or some association to link two tables of a database. Now, how can that be done? Or you can also establish relationships not between two tables, but rather between two columns of the same database. That all relationship is what is the main operation of a key. They play an important role in relational database in order to establish relationships or links between the different tables of a database. Now, types of keys are, these are the different types of keys: primary key, foreign key, super key, and candidate key. The most important ones which we'll be focusing on here is the primary key and the foreign key. So when I was talking about the ID of the user, or the registration number of the student, that is where the roll number, that is where the uniqueness is ensured. So when we know that the records of a table, that no two records can have the same information, or no two entities can have the same ID, or it's something unique. So that is where primary key comes into picture, and it also ensures that there are no null values. So a combination of the unique constraint and the not null is ensured by the primary key. Whereas the foreign key is where we have a relationship or a dependency between two tables. In fact, where, so for example, there are two tables which that's a parent table and a child table, we can say. For example, let's take the example of an employee table. So an employee will be assigned a particular department to work on. So there will be a department table having all the information of the department ID, the department manager, and so on. And the employee table, which will have all the information regarding the employee, like the joining date of the employee, end date of the employee, the department he is working on, and most importantly, his ID. Now the ID, we know that the employee table is dependent on the department table. So the table which is depending on the other table is called as the child table, and the table on which the child table is dependent is called as the parent table. So in the case of employee and department table, the department table is called the parent table and the employee table is called as the child table. So the child table will have the unique primary key rather. So it will have a primary key on the ID column, because the employee ID is where it ensures that all the employees are having their own unique identification number. That is where we are applying primary key. But the same primary key which we are applying on the department table, that is in the department ID. Now we know that the department managers, or each department rather, it is being assigned a particular ID to it. So the department ID also, and also the employee ID, they both are related in some way, because there we can establish a relationship between the child table and the parent table by making use of the unique column. That is the column on which the primary key has been defined. So there is a link established there. So foreign keys are where it ensures referential integrity. Now this is a concept which I'll be explaining in detail, referential integrity, and how foreign key is used, why it is used, and so on. Then candidate keys, as the name says, they are basically composite keys and candidate keys. There are slight difference. Composite keys are a collection of primary keys. Basically, two or more keys is called as a composite key, But what exactly is a super key and a candidate key? Let's dive in. Firstly, primary key, as I've already explained, in the employee table, ID can be the primary key since it is unique for each employee. So wherever there is unique to identify one and only one instance of an entity uniquely is where primary key is used. Combination of unique and not null. It also ensures that there are no nulls available. And also one important point you have to understand that each table present in a database, it can consist of only one primary key. That is, it cannot have more than one primary key for one table. There can only be one primary key. Then on that is only you can only define a primary key on only one column of a table, but not more than one columns of the table. Then coming to this is the employee in the employee table. Suppose these are all the columns. Primary key can be defined only on the employee ID because that is something unique. Coming to the candidate key, a candidate key is an attribute or set of attribute which can uniquely identify a table. So it is basically, as the name says, it is an attribute or a set of attributes. A column or it's a, but primary key on the other hand, it is a single attribute. It's a single column. It's the first key which is used to identify one and only one instance of the entity uniquely. But a candidate key is an attribute or a set of attribute which can uniquely identify a tuple. The remaining attributes except the primary key are considered as candidate key. The candidate keys are as strong as the primary key. So in the employee table, if I say employee ID was the primary key, all the other columns of the employee table, which is the SSN, passport number, these all, the name, address, passport number, license number, and SSN, these all are the candidate keys. And only the remaining key, which is the unique key having all the records or all the rows of the column unique, is called as the primary key. So the remaining ones are called as the candidate key. So these all fields over here, or these all columns of that particular table, are considered to be a candidate key. So coming to the super key is a set of an attribute which can uniquely identify a tuple. Super key is a superset of a candidate key. So for example, in the above employee table, employee ID and employee name. The name of two employees can be the same, but their employee ID can't be the same. Hence, this combination can also be a key. This is super key would be employee ID, employee ID, employee name. So a combination of both the primary key and the other, which is candidate key. And that is, it's basically super key is nothing but, you can say, as the word implies, it's a superset. It's a superset of the candidate key. So candidate key over here is only the employee name. But then the superset of that, which is also including the primary key with it, it's a combination basically. It is also including the primary key. So here it's the employee ID and employee name together. It can be considered as a super key, a combination key. So here, as it's demonstrated here, this is a super key. Then coming to the foreign key, which is really very interesting in our case, because now we were talking about each table, all the columns, how they are how they are actually related to each other in a particular table. But then when we have the tables, multiple tables in a database, there must be relationship between tables as well. For that, we are using foreign key, where we have a parent table and a child table, and the child table is dependent on the parent table. So that relationship of dependency of a child table on a parent table is established by a foreign key, and that integrity constraint which is ensured, the integrity which is ensured by the foreign key is called as a referential integrity. That is, one table which is called as a child table is referencing the parent table. As you can see, the department in the employee table, the employee table over here is called as the child table, and the department table over here is called as the parent table, because the department ID over here is also present in the employee. But then the employee ID over here is where the employee is basically depending on the department table. So this is where the child table and the parent table are dependent on each other, and there is a referencing over here, a referential integrity or a dependence between the parent and the child table, which is ensured by the foreign key. So it's a column of the table which is used to point to the primary key of another table. So you can see here, department ID and is called as the foreign key, whereas department ID in the employee table is called as the parent key. And in a company, every employee works in a specific department, and employee and department are two different entities. They're two different tables here. They're two different entities, they're two different objects or relations. So we can't store the information of the department in the employee table. That's why we link the two tables through the primary key of one table. We add the primary key of the department table, department ID, as a new attribute in the employee table. Now in the employee table, department ID is the foreign key and both the tables are related. Now you can see here that in the employee table, department ID is the foreign key, but in the department table, department ID as the new attribute in the employee table. So as you can see here, in the employee table, department ID is the foreign key. Here, this one is the foreign key present. But in the department table itself, department ID is called as the primary key. So both of them, that is department ID over here in the department table and in the employee table, both of them contain unique information. But then in order to link the parent and the child table together, we are establishing the referential integrity here. And that is done using the foreign key. So that was all about keys. Now that you have understood this referential integrity, it is really important for us to jump into the SQL commands now, because we have to now understand that how do we retrieve and access information which is present in the database. It requires it is very important for us to perform operations on all this data which is available in the database. That can be performed using structured query language commands. Now this is the division of SQL commands. So SQL commands are of 5 types. DDL commands, which stands for data definition language. You know that in SQL, you can perform using SQL commands. You can perform you can define the table which is present in a database. You can change its attributes, which is called the manipulation or the updation basically. So data manipulation language, DML. You can also control the access, the user permissions. You can grant a particular user as the access to the information present in the database, and you can also revoke their access rights. So that is taken care of by the data control language commands or the DCL commands. Coming to the TCL commands, it is transaction control language, where we are controlling the transactions present in the database. DQL is where it stands for data query language. So you want to basically access information or data present in the database, you're using DQL commands. Then DDL commands is there are sub categories or subtypes of DDL commands. The DDL commands are of 4 types. Majorly, it is create command, which is used for creating these the tables of a database. So basically, the schema of the database or even the relations, their schema or their structure can be created. So DDL commands are used for defining the structure of the database. Drop. So now there are very important aspects you have to carefully understand. The difference between drop and delete. They all some of them sound very similar. Alter is similar to update in the literal sense, but then why is alter and drop under DDL and why delete and update rather is in DML? I'll be explaining to you. Create, drop. Drop is basically to remove the the table from the database. If you do not want a particular table, for example, in the employee and the department table, there is another table in that particular database. There is of the company. There is another table which is called as, suppose, let's say the table name. Apart from the employee and the department table, there is another table which is the salary table, for example, and you want to for now remove the salary table, because some information from the salary table is corrupt, or you want to just remove it. So for doing that, you have to drop the table entirely. But dropping the table would remove the data as well as the structure of the table as well. But then if you just want to remove the contents present in that particular table, but not delete the schema or the structure of the table as it is, you just want to delete all the rows of the data of the table, then you have to use the delete command. Now you can understand that DDL is changing the structure or the schema of the table, but DML on the other hand, it's just dealing with the manipulation of data. That is, the data is either inserted, updated, or deleted, but nothing happens to the structure of the table. The structure of the table remains intact when you are performing DML, but when you are performing DDL, it is more like a permanent change which is done on the table, like create, drop, alter. Now alter is for changing the database or the table of the database. By you can add various constraints to the database. You can even add various data types to the data columns present in the database. These all can be done using the alter command, which is used for adding changes, constraints, and so on to the columns of the database. Then truncate is another command which is used for deleting the contents of the database. Now coming to the DML commands. Insert is used for inserting rows, records, nothing rows, nothing but records into the data into the column. So if you have created first, you cannot apply the DML commands unless the DDL commands have been applied. So basically, create is the first command you should, because create is for creating the table in the database. Now you have to, after the table structure or the schema is created, you have to insert the rows present in the database, and also assign them their different data types. Like data types, as I've said, the means of identifying the data. Like some columns can have only integer, they can only contain integer data type, like salary is one column, for example. Then you have to assign the data type to be integer data type. And for example, if the name of a employee is there, then, or a student, so the name can be in the character form, it can contain a string. For that, you have to use char or varchar. So you can change the data types present. So that is done using insert. Now coming to the update. Update is where you have to modify the data. So whenever there is a table present in the data, you can modify the table's information by using this update command. Then delete. Delete is one such command which is used for deleting the contents of the table, but does not delete or permanently delete the structure of the table. You can refill the table. Basically, you can add the contents of that. You can add the contents of new contents present in the table. Then DCL. DCL stands for data control language. Grant command is used for giving access rights to the user permissions, and revoke is for taking back those, or revoking the user permission, or not giving access to the user, basically. Then TCL, which stands for transactional query language. Transaction control language. So TCL is transaction control language. It's a particular type of SQL command, and the types are commit. When I was talking about ACID properties, I was telling you this important point. ACID stands for atomicity, consistency, integrity, isolation, and duration. Atomicity, consistency, isolation, and duration. So in this properties, you have to understand that whenever a transaction is done, it can be a bank, funds transfer, and so on. A particular transaction should be not be left partial, at any stage. It should be either be completed all at once or none at all. So in order to save those particular transactions in a successful state, for saving those operations successfully in the database, or the changes successfully in the database, you have to use this commit command. As the name says, commit means saving the transaction permanently. Commit implies that the data operation which is done in the database or the table is committed or saved as final. Whereas rollback is to undo the particular change present in the transaction. So in order to undo or roll back, that is roll back to the previous state from the partial state, is rolling back to the previous state. That is where rollback command comes into picture. Save point is like a checkpoint for us. Basically, whenever you want to save your work at a particular state, so that you can roll back to it later. For example, there is a particular step in the transaction process, and you have to just save your work till there, so that you're not sure sometimes that whether you have to continue or not from there, because whatever you're doing from that particular point may not be correct. So you are sure that whatever is done till that point, that is correct. So you can use the save point command of SQL, so that to save your work up to that particular point. So all the changes done up to that save point or that particular point are committed successfully, are saved successfully in the final state. But whatever changes are done after save point, you have to manually save them. You have to manually commit them. But if you want to roll back from whatever you have done up to that particular save point, that is where save point comes into picture. Now, data query language, as the word says, whenever you want to pass in a query to access information or access data from a database, you are making use of the select command. Then data definition, constraints, and schema changes. Constraints are like conditions we can apply on columns of a database. So as I was saying, you have to, in the ID column especially, you have to ensure that there are no duplicate records present in the particular column. So you can enforce the constraint or the condition. You can enforce, there's something like regulations, basically laws, or there rules or regulations which are set to the database. These are called as constraints. So unique constraint can be enforced there, where you have to ensure that each row of the column is to be unique. And not null is another constraint, where you have to ensure that there should not be any null values present in the column. Then they used to create, drop, and alter the descriptions of the tables or relations of a database. So coming to create table, this is the query. Create table is basically used for creating a new relation or a table of a database. Now, when I was talking about the data types, so here is a table. The table name is the department table. This is the query. Create table department. Then the columns are dname, dnumber, manager, MGR, SSN, manager serial number, then manager start date, MGR start date. So for these are just, you can be any column, basically any column name, but you can just assign any column, you can name them, and then up here these are the types, data types basically. So data types are means to identify the type of data. As you know that the department name has to be something in the string form. So you're making use of the varchar here. But d number on the other hand, it is integer data type. So you're using integer here. Then char is another, there's a slight difference between char and the varchar data type. Varchar stands for variational char and it saves the space. Basically, it is dynamic in nature. So, for example, if we are assigning a size of 10 here, but then there is a name in the particular column of the table department where the name is only of 5 letters. So, the remaining 5 letters which are not used are they're optimized in nature. So basically that particular name will only use up to 5 bytes. It need not use all the size which is allocated to it. But on the other hand, char is taking up the space. It is not optimized space because when you are assigning 9, it is allocating memory location as 9. And even if the name which you have assigned or the name which is entered into the database falls short or is less than 9 words, the remaining 4 characters, because if the name is 5 letters only, the remaining 4 letters are also occupied. The remaining 4 bytes of that memory location is also occupied, and we cannot optimize space. So, whenever you have the constraint of space complexity to be reduced, I suggest you to use and go for varchar. So char is especially used for smaller letters when you know that, for example, gender. Gender can either be in the form of gender can either be in the form of M or and F, because M stands for male and F stands for female. So for those kind of scenarios where there is only a one letter, yes and a no, Y and N, and so on. For those scenarios where we know that there is not much, the data is not too large. The variable name basically, the information entered is not too large. So for that we are using char. But if you know that the names are variable in nature, it can be of any, it need not be just 1 or 2 letters or need not be fixed size. For unfixed size or variable size, we prefer varchar, but for fixed size data types, we are using char. Then not null is the constraint which we are putting at the end here, and it is used for implying that there should not be any null values present in the particular column or in the particular attribute. So dnum and dnumber should not have any missing values. So this is all about it, how you're creating a table. Then coming to, first I'll be explaining you theoretically about it, and then we'll have a coding live demo on it. So creative table. So these are key attributes that can be specified via the primary key and the unique key. As you can see here, in the similar way as I've showed you, this is how you have creating the table. Depth is the name of the table. Create table has to be used in SQL. This is like the keyword specified. You have to specify the keyword. You have to specify, and then you're applying the constraints here. Now there is a primary key as a primary key which you are using. Now primary key is also a constraint here, and you are applying this primary key on d number, because d number is where it consists of all the unique information. Now you know that d name is also set to be not null, but we know that names need not be unique. Names can have the name of a person can also be same. That is why we are not using applying the primary key on the d name table, but we are applying it on the d number. And also one table at a time can contain only one primary key. There cannot be more than one primary key at once in the table. So that is why we are applying primary key on the d number. Then unique constraint is used on the d name here, d name column. Then foreign key MGR SSN references EMP. So I was talking about the referential integrity. This is how we have to, reference one table to another table. Now there is a link established between the DEPT table, that is the department table, and the employee table. the department table is referencing the employee table. Basically, we can say that the department table is a child table which is dependent on the employee table. Now, how is it dependent on the employee table and how is it related to the employee table? That is because of the foreign key. The foreign key which is present, and this is called as the MGR this is the foreign key. This is also basically a unique key, we can say, foreign key, which is nothing but the primary key in the primary key which is present in the employee table. So basically this key is referencing the employee table in such manner. So foreign after we are applying foreign key, inside the brackets we have to mention the column on which the foreign key has to be applied, like how we have mentioned the column or the attribute on which the primary key is applied. Similarly, for establishing a relationship between the parent table and child table, we have to enforce the referential integrity constraints, and that can be done using this command. As you can see here, this is the syntax of it. Now, unique is another constraint which we are applying on the D name here. Now, coming to the drop table. Drop table is used for permanently deleting the structure of the table. It is used to remove a relation or a base table and its definition completely. Drop table dependent. So dependent is the name of the table. You're using the syntax which is drop table dependent or drop table table name, that will completely eradicate the table or completely remove the table and cannot be, does not exist anymore. That's it. Then alter table is used to add an attribute to one of the base relations or base tables. The new attribute will have nulls in all the tuples of the relation right after the command is executed. Hence, the not null constraint is not allowed for such an attribute. So with this, I mean that, or you cannot have a not null constraint whenever you are using a alter table, because whenever you are create the new attribute, creating the new attribute, you're adding a new attribute using the alter table. So alter is this command here, alter table employee. Employee is a table name. Add job. Now job over here is the attribute or the column. Your employee table is missing this job column before. Now you want to add a new column to this employee table, which is called the job column. But you want to ensure that there should not be any null values, but you cannot do that. You cannot add another constraint here saying not null, because whatever column you are adding while altering the table using this alter table command, it is consisting of null values in all the tuples of the relation. Now tuples are nothing but the records or the rows of the relation. Now it is basically this is the syntax: alter table name, add column name, the new column name, and then specify the data type of the column, the varchar column, because job can be of the type of job is a string form. It's a string form, and for that you're using the data type as a variable character, the varchar. And here you're setting the size as 12, because the job, whichever, it can be a doctor or a engineer job, teacher job, and manager, etc. It whatever be the size, it should not exceed the size of 12 letters or 12 characters. So that is why you're setting a size of 12, the maximum size of 12. Then the database users must still enter a value for the new attribute job for each employee table. And to enter, when you were thinking that you have to enter a value for this job table, like job column which you have added to this employee table, in order to add the roles like manager, teacher, and so on, in order to add those, you have to use the update command, because update command, as I've already mentioned, it is for the data base manipulation, basically for the data manipulation language. So DML commands, for which you are going to use the update command basically. So features added in this one in SQL: create schema, referential integrity options. I've already just explained it to you. Create schema. Then coming to the referential integrity options, I've already explained about the foreign key, how we can establish a relationship between the parent table and the child table using this references keyword. Now coming to the referential integrity constraints on the foreign keys. Now there are four options which are in the referential integrity constraint of the foreign key. There are four options, which is restrict option, cascade option, set null option, or the set default option. Now what does this all imply? Here if you see, on is the basically to specify a condition or a option. Now whenever you're using an option like a cascade or cascade is one of the options, set null is option. You have to use it has to be followed. uh, that particular command option has to be followed after this on keyword. So you have, because it implies that this particular option is being applied on this table, on this foreign key. So in order to activate that particular the option, you have to use this on keyword here. So on delete, set default, on update cascade. It means that if the records of the child table are deleted, or basically if the records of the parent table are deleted, it should not affect the child table, or basically vice versa, that if the child table is the records of the child table are deleted, it should not affect the records of the parent table. In order to do that, we have to enforce some differential integrity constraints. So restrict is where we are restricting that. It ensures that the tables, the changes which we are doing on the parent table, it does not affect the child table. That can be enforced using this restrict option. Whereas on the other hand, cascade option is where cascade is like copying all the changes from the parent table to the child table. Whatever changes are done in the parent table, those will be cascaded or enforced again to the child table. Those will be followed or emulated by the child table. These are cascaded or passed on to the child table. Then set null. Set null is where if there is a change which is happening, or a foreign key is applied, or if there is a delete operation or an update operation, what should be done in that scenario? If there is any change which is done on the parent table, what action should be taken on the child table? That is determined with these options. So set null. Set null is when if there is a change like a update or a delete change which is happening on the parent table, and you have to you want to like set all the values of the child table to null, then you have to use this option, set null option. Similarly, on the other hand, set default option is to set all the records of the child table to default value whenever a change is or an operation is carried out on the parent table. So this is the syntax you can see here: on delete, set default, on update, cascade. This is an example. Then referential integrity, another options, set null, on update, cascade. These are some of the other an example. You can have a look at it where we are setting. And also you can see here there are two foreign keys rather. So basically a table can have more than one foreign key, but it cannot have more than one primary key. That is one important note we can observe from this example. Then additional data types. Data types can not only be integer, varchar, char, but they can also be of types date, time of I, and so on. So data types can have date, time, timestamp as well of data types. So when I'm talking about date, it is made of the year, month, day in this format. YMMDD. So this is the format which SQL follows for date. Whenever you have to assign any date, like date of joining, date of resigning of the employee, and so on. In this format, you have to insert the values into the records of the table while using the insert command. Then the time. It's also made up of hour, minute, and second in this format. This is similarly time of I. So coming to the timestamp, it has both date and time components, and data the retrieval queries in SQL. Now this is the DCL command where we are making use of the select query. And so basically, whenever you want to select a chunk of data from a particular database or a table, you're making use of the select command. So basically, to select only some part of the table which is present, that is done by the select statement. Then retrieval queries, attribute. Okay, so this is an example where, for example, you want to only retrieve like let's say in the employee table only the employee name and the employee ID. Then you specify select employee name, comma, employee ID from employee table, that is the table name, where the condition, where department equal to manager, for example. So where is the keyword which you have to use for specifying a condition. From is for filtering the data. So this from basically is for we can say whichever table or the entity from which you have to extract the information, you are making use of the from keyword. Select attribute list, whatever you want to retrieve the data or access information from that table or the database, you are making use of the select command, the DCL command here. These are self-explanatory terms here as mentioned. Then relational database schema. Okay, this is just the top level view on, I'll just be skimming through this, and then we can get to the practicals where I'll be explaining you how all these commands can be executed. See, I was saying you, if you want to just select the SSN dname command from the employee and the department table both at once, you can do this. Select SSN dname from employee comma department. It is extremely important not to overlook specifying any selection and join conditions in the where clause. Otherwise, incorrect and very large relations may result. So you have to, in order to filter data, basically, whenever you are filtering data, you're using where clause, because if you specify where employee name equal to some name, employee name equal to ABC, so only those records pertaining to that particular name ABC will be retrieved to you. That is the SSN, the serial number and the name of the employee which is having the employee joining date, or the employee joining date is something specified, or the employee name is ABC, only those will be retrieved to you. So it is used for filtering the data. As I've said, select and star is one important thing. Use a star if you want to just have a overview and not just specific columns from the table, but you want to view all the columns and access all the columns of the table. Simply use a star. Star means all, so select all or select star is nothing but same operation. So select star from employee where D number equal to 5. This will retrieve all the attribute values of the selected tuples. It will retrieve all the column values of the selected rows. Star is used, which stands for all the columns, all the attributes. Where department number equal to 5. So all the employees records will be retrieved and displayed to you who are having the department number as 5. Use of distinct. Now distinct is for eliminating the duplicate tuples. So whenever there is for example salary may be the same for many of the employees, but you want to only select the distinct salary, or to eliminate the redundant or the repeating tuples in every query result, and only give the unique or the distinct. Unique and distinct are same. In SQL we are making use of the distinct. Unique is a constraint in SQL language rather, but distinct is the keyword which you are using to imply that you want to only filter out the distinct or the non-duplicate records from the table. So you're using select distinct salary from the table name employee. This will only give us all the unique salary values of all the employees present in the employee table. Set operations. SQL has directly incorporated some set operations, and there is a union operation, intersect operation, minus operations, and so on, in such a way that these all different resulting operations of these set operations are sets of tuples. They're nothing but sets of rows, and duplicate tuples are eliminated from the result. So there are various operations you can apply on the on the queries, as we'll be seeing. And is another keyword you have to understand, that wherever you want to specify there is a condition like this, and you want to make sure that both the conditions should be evaluated, both the conditions should be set to boolean true or to be checked. We are making use of the and command, and or on the other hand, or keyword on the other hand, or operator. Basically and or are logical operators. So this is because whenever you have to check that the first condition, which is this one, num is equal to D number, and the second condition, which is MGR equal to SSN and L name equal to Smith. These all are the different conditions, part of one particular where clause. So in order to segregate the parts into different segregate this where clause entire condition into small parts or conditions, you're making and joining them together, you're making use of this and operator, which will ensure that all these conditions or checks are set to true. Whereas or on the other hand is for that any one of the conditions should evaluate to true. So nesting of queries. Queries can be, you've heard of nested loops and so on. Nested is one particular query inside the other query. There can be various inner queries inside outer query. That is nothing but nesting of queries, which is also allowed in SQL. So I'll be explaining you everything. Aggregate functions are one important function. Type of functions you have to understand. This will all come handy where you are dealing with database management systems to in order to filter out information and what kind of information. So for example, you select, basically as I've told, it performs a lot of operations. So whenever you want to access data and filter out information, you can, there are ways to access that. So when you want the maximum salary from a particular column, you can use the max command here. So aggregate functions are nothing but group functions, and the five types of aggregate functions are, namely count, sum, max, min, and average. The name says it. Count is used for counting all the values present in a particular column. The sum is used for summing up or finding the additional addition, the sum of all the values present in the particular column. Max is for finding the maximum value in the particular column. So if I say salary, max of salary, it will return me the record or the tuple having the maximum salary. The maximum salary in the entire salary column will be returned. Minimum salary will be written using min. Average of that, but all the salaries present in the salary column will be given by the AVG, that is the average command. Count, on the other hand, will return all the tuples, all the rows of the salary column to me. Sum, on the other hand, will sum up all the salary values present in the salary column and return me the sum of it from the employee table. This is basically, the syntax to be followed, and it may not allow more than one function in the select clause. So what happens is max of salary, comma, min of salary. You can see that max, min, and average, there are three functions here, but some SQL implementations may not allow more than one. Sometimes it allows only one, that is max of salary from employee. They're various, because see, SQL is a structured query language and it's used in various RDBMS. So RDBMS can be of various types. If this is allowed in MySQL, it may not be allowed in Oracle, or vice versa. So PostgreSQL is another another example. So basically, there are various RDBMS, relational database management systems, and they follow different SQL implementations. There's SQLite, SQL Server, MS SQL Server, and so on. So this is a small gist about all the aggregate functions, and a small summary of the SQL queries I'd like to give first before explaining you the demo of them. So this is the basically select attribute list for selecting, or DCL command for retrieving all the information you want from the table list, from which table you want to extract the information from, where the condition should be specified here. Group by, the grouping attributes, where whichever you want to, for example, you want to group columns together, you can use the group by command. Then having, for specifying the group condition. Now, where is different from having. Where is for specifying a condition, but having is used for specifying a group condition. So whenever using a group by statement, then only having should be used. Otherwise, group by and having should be used together, but the having cannot be used without group by. Then order by is used for basically, sorting the data. So as the name says, ordering the data or the attributes of the column in the ascending order or descending order and so on. So if I say order by salary, order by salary, it will return me all the records arranged or ordered in the ascending order. The default is ascending order, but if you say order by salary DESC. DESC is a keyword for descending. So it will then sort all the records in the present in the salary table and return me in the descending order. So that was all about it. Then insert, delete, and update are DML commands, which I'll be explaining you practically. How to insert all the rows present in the table, then how to delete them, and also how to update the particular rows present in the table, and so on. You can just have a look here. This is a query, insert into the table name values. Now, whatever value you have to insert into the particular table, you have to mention the strings in the form of inside the quotes, quotation marks. But whenever you're even the characters and the variable characters, they have to be presented or included in the form of quotes. But whenever using numbers or digits, that need not be that should not be put in the form of quotes, because they are numbers, they're integers, they cannot be enclosed in the single quotes or the double quotes. But strings, on the other hand, or alphanumeric as well, like 98 oak, it consists of both the number as well as the alphabets. They should be put inside single quotes or double quotes. And attributes with null values can be left out for the insert. This is how you're inserting values or records into the table, employee table, as you can see here. Then this is the insert table command. Then delete, on the other hand, whenever you want to delete information from table, you need not specify like delete star. If you want to delete all the contents present in the table, you do not have to write delete star like how you were doing for select star. Rather, you have to use delete all, or simply if you use delete from employee where L name equal to Brown, that will delete all the contents present in the employee table. So you cannot use delete star or delete all here. Use delete from. Delete from employee, that is the table name, where the condition last name is equal to Brown. So it will delete all the rows from the employee table which are having of the employees which are having last name as Brown. So where condition is what is helping us to filter out information. It is helping us to delete only those records which we actually want to delete from the table. But then if you just simply do not mention the where statement, just say delete from employee, all the records from the employee table will be deleted in one go. Then update statement is used to modify. It's a DML command and it's used to modify attribute values of more than one selected tables. You want to change the name of an employee. An employee is ABC. You want to change the name to XYZ. You can do that using the update command. Something like this. There is a project here and update project. The project is the table name here. And here is like example, change the location and controlling department number or project number 10 to Bel Air and 5 respectively. So you're changing the two column values here, not only single. You can change any number of column values you want at a time. So update the table name, set P location, the column name, to Bel Air, and dnum, that is the number, the project number, to 5. From 10 you're changing to 5, where P number equal to 10, because you want to change the project number of that particular project which is previously assigned the wrong value of 10. You want to change it to 5. You're using the set command. So set is this keyword here in the update statement. A set should always be used whenever you are replacing the old content, the existing value, with a new value. So set P location equal to Bel Air, dnum equal to 5, where P number equal to 10. So where is the command which you are using, where clause here, in order to filter out information. You're specifying the command, specifying the condition that P number equal to 10. Then you're updating the project here. You're updating the table here and setting the value here. So the location will be set to Bel Air and the number dnum will be set to 5. The new values. So that was all about it. Where this is another example where you are updating the employee table. Give all the employees in the research department. Now see here, whenever it is specifying something that you have to give or you have to change the values of some particular thing, you have to understand that in the where statement it is what this information should fit into. So it says employees in the research department. So you have to understand that department name should be research, and that will fall under the where clause. Then update employee, the table name, set, what is it saying? Give all employees in the research department a 10% raise in salary. Now you want to, now how do you calculate the 10% raise in salary? The new salary should be updated as salary into 1.1, because 10% means 10 by 100 into the old salary. Now 10 by 100 is nothing but 0.1 into the whole salary. So 0.1 plus 1 should be added, because you have to add that particular to the old salary. So that is what you're doing here, updating the new salary with this value here, salary equal to salary into 1.1. By doing this, the old salary gets changed and each employee in the research department will get an increment of 10% in their salary, and that will be reflected in the salary column of the table. Then where D number, where the department number is in select. See, this is a nested query here, because you're using a inner SQL query into an outer SQL query. This is how a nested query is coming to picture here. So where D number in select D number from department, where D name is equal to research. That was all gist about it. Recap of the SQL queries I have already given and explained this to you. So I hope I have made all the theoretical information really clear to you about what exactly are SQL commands. That was the last part about it, and I will be giving this the practical demo I would like to show. So we'll be dealing with some basic commands of SQL which I've dealt with, because for more practice I'd recommend you to practice it hands-on on MySQL Online Editor. There are various editors, and if not MySQL, you can also install Oracle. So there is Oracle SE 11G edition, You can install that into your system and then you can run there. You can also install MySQL server into your local PC and then practice these commands. So for now, for a demonstration, I'm using this online compiler. See, you can see here, create command. I've already, for the demonstration save and saving time, I have, already entered the commands here. So for you to understand, so for creating here, create table employee, which is the employee table, emp id, name, and dept, the department, are the different attributes or the columns of the table. Then integer, text, and text, these are the different the data types of the table which have to be specified, followed by the constraints. Now constraints is up to you. You may or may not specify them. They are like rules and regulations to your definition of the schema of the table. So it's always good to add constraints because it gives us a clarity. Because sometimes what happens is, if we forget to apply constraints, we later have to add those, and it will take a lot of time, making use of DDL commands, because always we say DML is very easy to manipulate the data. We need not change the structure of the data, but then sometimes if you do not add this primary key and later you wish to add it, you have to add the constraint, and for doing that you have to use the alter table statement. As discussed, you have to use the DDL statement, the DDL command, which is alter, by saying alter table employee, then add constraint primary key, where, so on, where the condition. So that all should be done. So instead of doing that, while you're creating the table itself, you have to, it's always a good practice to, add the constraints there. Even if it's a foreign key, you have to add it inside, like while creating the structure of the table. So you can do this. You have added the constraints, which are primary key here for the employee ID column. For the name and the DEPT, you have want to ensure that there should not be any missing values, or there should be no null values present in these two columns. So you have mentioned them using the not null. Then insert into employee values. Values is one important thing. So see, you're inserting into employee column, employee table here, but then one by one you have to insert it as a record into the particular table employee. So these should always be ended by semicolons. One important fact you have to understand, that while you're creating it, this is the exact syntax you have to follow. See, these names and all these can be changed by you, but then this is a syntax. If you forget even a semicolon, for example, after this insert, the query would not run. To separate and go to the next query, once you have successfully created the row, inserted a row or record into a particular table, you have to use this semicolon, because semicolon will then only create the or insert the record into the table successfully, and then transfer the control flow to the next statement. So insert into employee values. Then here you have to give the employee ID, because employee ID is the first column. As you can see in the output, for the clarity purpose, this is the employee ID. You can mention any employee ID here, but make sure that you're not enclosing them in single quotes or double quotes, because they're numeric in nature or they're integer in nature. These are the different standards you have to follow. Always you have to follow while writing SQL commands. You have to convert your logic, your thinking approach into these SQL commands. It's something similar to the English language only, but you have to follow this syntax as it is. Then the name of the employee has to be mentioned in single quotes. It can be any name. Then department has to be mentioned here, as sales, accounting, so on, anything. Then fetch. Now here for fetching, this now create is a DDL command, insert is a DML command, and fetch is a DCL command, or the data control language here, because we are fetching the data, or we are retrieving the data from the table, employee table. So now we want to retrieve all the values or all the records from the employee table. So we are using select star from employee, where DEPT equal to sales. By doing this, all the columns of the table will be retrieved. All the columns of the table will be retrieved at once. So this is all about it. Select star from employee, well, DPT equal to sales. But now here, using this where command, that is only for the department, that is sales, this department. So basically employees with employee value 1 and 3, because they are having the sales, they belong to the sales department. Only the records of those two will be retrieved here. Now if I remove this where DEPT equal to sales and run this, you can see all the records fetched. But now instead of this, you are mentioning select a particular column. You don't want the, for example, say you do not want to know the employee ID, but you just want to know the name and the DEPT. So for now, select name, DEPT, specify the attributes or the columns you want to fetch from the table, and then from employee. For now, this is what you want to. Then this will fetch us the two columns, the name and the DEPT column with all the values. Now, where? Let us give us a different state. Let us now it's now see this. I'm making it now. Let us see if MySQL is case sensitive or not. The SQL is case sensitive or not. You should understand that SQL is not case sensitive. You can use lowercase as well, uppercase as well, but always, and it's a good practice to keep the reserved keywords in the form of a uppercase values, because that's like, see, select, from, where, these can be lowercase as well. You may write them in smaller characters, small letters, but there is always a good practice to write them in capital, because that will distinguish these words as the reserved keywords and the important words of this SQL command. So where, suppose, let's just say, instead of filtering it on the DEPT, let's make it more specific by saying that the name should be only Dave. I only want to I only want to access the record or fetch the record of Dave, and that to which department he belongs to. So here I get the department of Dave, which is accounting. So that is the one. This is ways in which we can manipulate information, access information, and retrieve them. Whatever commands I have discussed now, I recommend you to practice them hands on, because that will give you a better understanding as to how those can be held. I've given a brief overview about database management system, what are the SQL commands, and how can relationships between the tables or even the columns of a table be established. The same, and also what are the advantages and disadvantages of database management system, the properties and characteristics of database management system, SQL, which are the different classification of the SQL commands, which are the DDL commands, the DML commands, the DCL commands, TCL commands, the transaction control language, and also I have explained you in brief about the user permissions, how they can be updated from one user to another. And in short, I really hope that you have now gained an interest to learn database management system, because that is one important key skill, I would say, which is applicable in various enterprise level jobs as well. Thank you so much.